Okay, I've had a request to do questions 4A and 4C from 11B. I felt that it would be best if I did these for all of you if I did it as a video. So that's what I'm going to do. We'll start off with 4A and then go on to 4C. Okay, so this is question 4A from 11B. What we're going to do here is we're going to integrate the following function. And just like if you ever get a chance to do a bit of DIY, the prep is where it all matters. It's all in the prep. And integration is quite a lot like doing DIY in that respect. So the first thing that we need to do is we need to get this ready to integrate in the same way that you would sand down a surface before you paint it. We're going to take that 3, we're going to split up into 2 integrals, and we're going to take the 3 outside. So we're going to write this first part of the function as 3 sine 2x plus 1 dx, and we're going to do a second integral here. We're going to take the 4 outside of the integral, and we're going to write this as this bracket now as 2x plus 1 to the minus 1 dx. Okay, next stage is to integrate this here. Now, you know that the integral of sine is minus cos. So you'll have a minus cos 2x plus 1. We've got the 3, which we've still kept. We've just left it well alone. That's why we took it outside. But if I was to differentiate this, of course, the cos would go to minus sine and the minus would cancel and you'd end up with sine. But we'd also have to differentiate what's in this bracket here. And if we differentiated what's in this bracket, we'd get a 2 that would come out and go here. And we do not see a 2 in the first line. In the first line, you don't see a 2. But in the second line, we would get a 2 out when we differentiated. So we need something to negate it, to cancel it out. So we are going to put a half here, because a half times 2 is 1. Now, on the other bit, you've got the 4, and because it's this bracket here is to the power of minus 1, that means that we're going to get a log that comes out. So you're going to get log 2x plus 1. Now, in the same way as previously, that if we were to differentiate this, we would differentiate the log to get the bracket to the power of minus 1, but you'd have to differentiate what's inside the bracket here. So if you differentiated that, then what would go here is a 2. We do not want a 2, there is no 2, but you can see up here. So we write a half, and we have to do 4 times a half. Don't forget, at the end of this, we need our arbitrary constant. So we now write this as minus 3 over 2, 3 times a half. Just make that clear that that is a negative there. Negative 3 over 2 cos 2x plus 1 plus 2 log 2x plus 1 plus c, the 2 coming from 4 times a half. Okay, so that's question 4A. Let's move on and look at question 4C. Okay, so question 4C, like question 4A, and like, I don't know, painting some architrave, it's all in the prep. So let's get on and do the prep for this. Right, okay, 1 over sine squared 2x. Now, this is interesting. I think this would be more confusing after the next few lessons when we've got lots of other tricks up our sleeve on how to do integration. At the moment, you've only got one way that you can go with 1 over sine squared 2x, and that's to write it as cosec squared 2x. It's one of those weird situations where actually ignorance is bliss. The less you know about this, the easier that is. I think this question could send you down some blind alleys if you knew a bit more about how to integrate trig. Well, you've got that coming. Oops, I shouldn't have written that. I should have written 1 plus 2x to the minus 1. I was so content on telling you about how or so into telling you all about how you don't know stuff that I made a mistake. There's a lesson in there about life if you want, probably. Okay, anyway, so that goes to 1 plus 2x to the minus 1, and this goes to 1 plus 2x to the minus 2 dx. Now, cosec squared integrates to cot. You get that in your formula book, so you get cot 2x. Now, of course, if you were to differentiate cot 2x, you'd get a 2, or it's a minus, sorry, it's a minus cot 2x. Of course, you'd get minus 2 that would come and it would go there, and we need to cancel that 2 that is there, so we're going to write this as a half, so you've got minus a half cot 2x. Just like the last question, when we do the integral of something to the power of minus 1, you are going to get log 1, sorry, log, let's just erase that. You get log, and I want my mod sign, 1 plus 2x. And of course you differentiate this, you get a 2 that comes out the front. So you differentiate this, it comes out the front. Keep on forgetting that you can't see my cursor. I'm keep on using it to point with and you can't see it. So we need a half there to negate the 2. And here, it's lovely this question is because this to the minus 1 leads us to log to the power of minus 2. We get another bracket out. I'm going to put a plus c here because I won't forget it. I'm going to put a minus 1 here because we have to add 1 to the power. And we've got a 1 plus 2x here. Now, if I was to differentiate the power, that would come down and we'd just get minus 1, which we don't want. We want a negative there because we want the minus 1 times the negative to give us the plus up here. Probably better just writing a minus here all along, but we didn't know until we started integrating. Just watch out for those little things. And then if I was to differentiate this bracket, this 2 here would come out in front, and of course there is no 2 here, so we need a half. Okay, right, let's tidy this up. You've got minus a half cot 2x. You've got here, I'm going to write this as log 1 plus 2x. God, my 1s and my mod signs look similar. Turn that into a 1. Okay, and then that's over 2. The 2 here. And then the plus and the minus go to a minus. You've got the 1 plus 2x as a fraction. But let's not forget this half here. So the half would times, so you just get 2 on the bottom because you just times a half by 1 over 1 plus 2x. And let's not forget our arbitrary constant of plus c. And there you go. Questions 4a and 4c.